Okay, there we go.
Okay. Heavenly Father, we're grateful for this day. We're grateful for the opportunity we have to get together as a group and talk about trigonometry. We ask for thy spirit to be with us so that we can all be taught and learn and edify one another. And we say that in the name of Jesus Christ.
Amen.
All right.
Okay.
Discuss and make.
Oh, sorry. Go ahead.
No, you go ahead.
You're good.
I was just reading the instructions for the Google Hangout.
Oh, okay.
I guess it says discuss and make sure each team member can define radians.
Yes. Basically another way to express degrees.
To tell you the truth, I have not. Oh, I haven't looked at it this week, but I had a good calc teacher in high school, so I kind of remember this stuff.
That's good. I just watched like 2 YouTube videos that taught me everything on it.
Nice.
Yeah, that's what was in the resources thing, wasn't it?
I don't know. I just saw we were starting trig, so I just looked up trig videos and was watching them today.
Yeah, the resource videos are pretty good, but I like the links on the side of the, like, not the video she gives, but sometimes the other videos have helped me more.
Yeah. I watched one with some lady. She did a good job of explaining it. So I think the definition I got from that video that I wrote down is a radian is the degree of an angle that travels 360 degrees around a circle. I don't really know how to explain it or what it is, honestly, but
Yeah, that makes sense.
Cool.
It's a ratio around the circle, I think.
Yeah, using the pi.
Yeah.
Good old pi.
Did everybody fill out their unit circle?
I did.
I got online and typed in the unit circle, so
Oh.
I got.
Oh, nice. Yeah.
Hey, fancy.
Smart. Does anybody have questions about vocabulary?
I don't think so.
Okay.
Yeah,
All right.
good.
Yeah, a lot of it looked familiar. It's just I actually need to go through with all of what she posted for us, because I haven't had time to do that yet.
Yeah.
I've been pretty busy with my job, so. But are we ready to go over one?
Sure.
Okay.
Okay, so I went through all this already, so if you guys want.
So this one says to find the following values using the unit circle, and it's like be sure that everyone in the group does at least one and explains their answer. So I guess we can all pick one and then maybe review them together since there's 5 of us.
There we go. I'm in here now finally.
Oh, hey.
Hey.
I don't know what was up with my computer, but it wouldn't let me join for the longest time.
Oh.
But now I'm here.
Glad you made it.
Okay. I just got done with a live stream. That's why I have my humongous headset on. Okay.
Well, I can do sine of 7 pi.
Wait, so are we just converting these ones over into degrees, or?
No. So you know the little parentheses off to the side of each thing? So you go to, for the first one, you go to 4 pi over 3. And that's degrees. And since it's sine, you do the y-intercept, so it's -3 or negative square root of 3 over 2.
Mm-hmm.
If you have a calculator and you put it into radians and you put in sine, yeah, it'll do it for you.
I can do the first one, the 4 pi over 3.
Okay. I'll do 7 pi.
I guess I'll do cosine of -9 pi.
I'll do cosine pi over 3.
I'll get sine 7 pi over 2.
All right, did we all get the answers already?
Yeah.
Yeah.
I'll just start from the top and see what we got then.
So, sorry, real quick. So, is sine the y value?
Yeah.
Yeah. And cosine's the x.
Okay. Do you have to simplify them out into a decimal, or does it still want it as a fraction, or does it matter?
I think it gives it as a fraction.
Okay, because the 4 pi over 3 is the square negative, I think, square roots of 3 over 2.
Yep. Sine of 7 pi is 0.
Okay, and then the sine of -7 pi over 2 is -1.
And the cosine of -9 pi is -1.
Cosine pi divided by 3 is 1/2.
I think it also wants us to explain what we got, or like how we found that.
That didn't my calculator.
Right.
So what I did, So it says to use the unit circle after we fill it out. And so what you do, well, what I did is, so it's, mine is -9 pi, and pi is just 180. So the negative means it's going clockwise, starting 2, 3, 4, blah, 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 until you get to, so -9 is this angle right here. And over here we have the x and y intercept, and I just picked the x-intercept for that, which is -1.
And which one was yours originally?
Negative, or the cosine of -9 pi. And you can do that with any of them. And just find it on the unit circle graph.
That's what I did.
Yeah.
Oh, yeah. Makes sense.
So the cosine of 7 pi over 4 is square root of 2 over 2.
Yep.
And then cosine or sine of -5 pi over 4
Is -pi2 divided by 2? Or no? Wait.
The square root of 2? Wait, or am I looking at the right one?
Yeah, square root of 2 divided by 2.
negative square root of 2 divided by 2.
Okay, and those are both negative since they're in that quadrant. Oh, okay.
No, we're going clockwise. I read cosine, sorry.
Wait, so what does the negative in front of these do to it?
It makes you go clockwise on the circle instead of counterclockwise.
Oh, so you'd kind of have to do basically the opposing.
Yeah.
Yeah.
So what degree? So for that one we just did the -5 pi. What degree?
So
would that
would
be 135 degrees?
Yeah, and then it would be the y. So it's the square root of 2 over 2. I read the cosine accidentally.
Okay, that makes sense. Cool.
It's the angle at which the radius is the same as the arc length. And so
You have to feel pretty comfortable with the first chunk.
Yeah.
Yeah. We can move on to question number 2 then.
Okay. Let's see. The fundamental theorem of trigonometry is an important identity. To have you better understand this theorem, answer the following questions as a team.
So first we find the sine of the pi over 3, which is square root of 3 over 2.
Mm-hmm. And cosine is 1/2.
1/2.
Mm-hmm.
And since they're both positive, we go clockwise, right?
Right.
Yeah.
No, counterclockwise.
Oh, yeah. We go counterclockwise.
Oh.
You'll go up to the circle.
Yeah. And then what you do is you take those. So you take the square root of 3 over 2 and you square it, and then add it to this 2.
1/2 squared. So it'll be 1/4 plus 3/4.
Yep.
Just one.
That's always going to be true.
Yep.
Yeah, and so each time you do that step, it's going to give you 1, right?
Mm-hmm.
Okay.
Because it has you do it a couple more times with pi
Yeah.
over 4
Yeah, the
Pi over-
ace.
and then pi over 6.
Yeah.
It says, why do you think it works this way?
Well, isn't it the triangle?
Theorem.
Yeah, that's it. The
Yeah.
a squared plus b squared equals c squared.
Oh, okay, I can see that.
And that's kind of what it's explained in question number 3. But, yeah, the Pythagorean theorem each time is used. Hypotenuse will always be 1. And then it explains that the cosine squared of x plus the sine squared of x will equal 1 because x squared plus y squared equals 1.
Yeah.
Okay, then it substitutes the x squared plus y squared equals 1, and it just substitutes the cosine and sine squared, which will equal 1 according to the Pythagorean theorem.
Yeah.
Yep.
Okay. Pretty cool. And then it specifies, I guess, that it's important to know cosine squared of a value of x is not the same as cosine of x squared because those aren't interchangeable, which, I mean, I guess is pretty clear, but I always get tripped up by stuff like that.
Yeah, definitely. Okay. Use your book, section 5.2, to discuss the formula for the motion of a spring and go through the practice problem.
Oh boy.
Yeah, oh boy, he's right. So it's on page 359.
Textbook always hates loading when I'm on one of these, when I'm on the group thing.
No, my computer's always so slow.
Sometimes this textbook takes so long.
Does anybody have it up? Not yet. Okay. Just suggest screen sharing.
What page was it?
Page 359.
Loading page, loading page. Okay, example 8. That was a question. 5 just here. Okay. Does everyone have it up? Mine just finished loading.
What was the page number again?
359.
315?
59.
59? Okay. All right, I got it.
I'm still waiting, but go ahead and start.
One of you guys could screen share it if you want to throw it up on here. Mine's still loading.
I've actually got mine on my laptop, so I can't.
The screen share.
Does that work? Oh boy.
Whoa. Whoa.
Oh, dude, that's cool.
Wow.
Never mind then.
There it goes.
I usually use share a window. That way I don't get that nice little repeating effect going.
Sure, there's an equation for that too.
Probably.
Okay, I got it pulled up on mine.
Hmm.
Really?
I want top hat.
That was the whole burrito. I don't have a sweat problem with that. Nom.
There we go. Perfect.
That one.
So let's see.
Weight on a certain spring is set in motion with an upward velocity of 3 centimeters per second from a position 2 centimeters below equilibrium. Assume that for this spring and weight combination, the constant has the value of 1. Write a formula that gives the location of the weight in centimeters function the time t in seconds, and find the location of the weight 2 seconds. After the weight is set in motion, its upward velocity is negative.
Is this the, you see the figure 5.35?
So V0 is initial velocity. So initial velocity, upward velocity of 3 centimeters. So the initial velocity is 3 centimeters since -3 since it's upward. And above equilibrium is negative. Kind of trippy.
Yeah.
Okay. I'm trying to scroll on the screen and I'm wondering why it's not moving because
X.
Yeah. Well, no, because here in degrees you're saying
That's
2 degrees,
2 seconds.
and here you're saying the side of 2 radians.
Oh. That makes sense.
well, they use a graphing calculator in radian mode.
Negative 3.56.
So what is it wanting us to do? Go through this problem to discuss the formula.
I think it's just wanting to make sure that we understand what's happening. Cosine. Whoa. Since upward velocity is negative, okay, if 2 seconds, then x is, okay. Okay.
What tells you where sine and cosine go? Is it a positive negative thing?
What do you mean?
Or is that just the equation for it? With like the -3 sine t plus 2 cosine t.
Why is it not flipped?
Yeah, for example. Oh yeah, or I guess that just goes back to the Pythagorean theorem that with x and y, and you just putting in cosine and sine, that their
Yeah.
values just go into place. Okay, I think I'm seeing.
What we needed to go over, or was that it?
Well, I think it talked about the practice problem, which I don't know if that's just the try this under there, but
Okay.
I mean, I guess that one, like, we can kind of infer the same thing, how it's like it starts with the negative sign, so that would be, let me see, so that -2 would be its velocity. Like, I know it's not part of the problem, but that would be that spring's velocity.
Yeah, going upward.
Up. Okay, at 2 centimeters.
Uh-huh.
Okay, and then 3 cosine would have started 3 centimeters below equilibrium.
Yeah.
$3.1. Is that what you guys got? Oh wait, with on a 3. Sorry, I did something wrong.
The calculator, trying to use Google's, but their calculator is terrible.
So what does the 2 in the parentheses stand for?
Are we just doubling the time then, or?
It's the amount of time in seconds.
So this one is, yeah, since this one is 2t, it's...
Yeah, I guess I don't see why this one gives the 2t, unless that's just the formula they give. Because, like, why couldn't you have the same formula without the 2 and just use t seconds?
Yeah, I mean, yeah, I don't know. I guess it's just a formula. Just 6
Yeah,
seconds.
I'm like, that's the formula they say to use, so maybe that's why.
Yeah, just... I got 3.4.
That's what I got too.
Okay, cool.
So if that's positive, that would mean that it's that it would be below equilibrium, right?
From what I got, yeah.
Yeah, because if yeah, upward velocity is negative and locations below equilibrium are positive. So if it's 3.4, Positive 3.4.
3.4. Right? Centimeters.
Yeah, positive.
Okay. Yeah, so then it's positive, and then since all the values are in centimeters, I would assume that's centimeters below whatever the equilibrium point,
Yeah.
or I guess normal.
Good.
Yeah, I think that's just all it's asking us to find. Whoops. Let's see the key. Yeah, it doesn't. The key doesn't tell us anything about it per se. So, I mean, I'm just gonna assume that makes sense.
Yeah, just to go through the practice problem is all, so that should be good.
Okay. Well, does anyone have any other questions?
No.
Are you guys able to meet on Friday instead of tomorrow, or do you have dates or anything going on?
I could do Friday.
I don't think I have anything Friday, so I should be good.
What time Friday?
I should be good after 6, whenever.
Okay, because I'll try to work with y'all's schedule. I can plan it out.
Would y'all want to do like something like 7 just to make sure everyone's good on time?
Is that all right for you, Addison?
That should be fine. I think that's what, 8 my time? Yeah, that should work.
I might be able to do that. If earlier, it might be better as well.
Okay, I can do earlier too. I don't know if anyone had to work late or something.
No,
I shouldn't have to anymore.
I'm just usually busy Friday nights.
Jump for 6.
Try to be busy at least.
6:15 is probably when I would get home from work.
6:15.
30?
Okay, let's do 6:30.
Yeah, we'll shoot for between 6:30 and 7. We'll start. That'll work. I'll make it work. So sounds good.
Sounds good to me.
I don't have any obligations anymore. I'm not working because my son needs round-the-clock care now, so makes me free.
All right, sounds good.
We'll see you guys then. I'll get this posted, okay?
All right.
Thanks.
See you guys.